Hi folks, this is homework number 5, problem number 2, and it's fairly uh, open in the sense that it's left to you what dimension you want to choose, what material you want to choose, etc. Uh, but what I want to do is, and there's zillion different ways of doing this problem. What I want to do in this homework is do this thing with shell elements first of all, and use planes of symmetry. It's a flywheel which is rotating at a constant speed, and you're asked to ignore these holes there. And when you look at that, if there are four holes here, big four holes here, then all you need to do because of symmetry, you need to take one. That'll be 1/8 of this disk basically, so like that. And I want to do it in a long way so that you can get to see some of the issues that are involved in creating surfaces. Okay, now of course you can make a solid object like that and select the top face, extract the top face, and then make cuts but I don't want to do it like that. Okay, I want to do it a couple of ways that actually they will fail, but they will lead you to where you want to go. Okay, so let's go ahead and start with a part file. And because I'm going to be doing surfaces only, I have to be in generative shape design or wireframe and surface design. If I go to part design, then obviously I have to extract surfaces later on, but I don't want to do that. So let's save this thing, file, save management, save as. I have a folder here. Let me go up one level. So problem 2. Okay. So on this horizontal plane, I will sketch. Let me draw a circle here. And these dimensions, let's see now, my dimensions are in inches. So let's see now. This is radius. Let's make it 5. How about 10 inches? Radius 10 inches. Okay, good. Now, on purpose, I'm going to create a circle here, right there, and whatever dimension. So let's make that radius 1 inch. Okay, good. Now, what I want to do is create 4 of these around here. So I've never used or shown you how to do this rotate thingy. See that? Rotate. It says how many you want. I want 3 pieces. And if you read the bottom, and this is the one that you want to rotate. Notice that at the bottom left corner it says select the thing that you want to rotate, and then select or center the rotation center point. So this is going to be there, okay. And notice that uh, when I do this, you see this? When I turn this line around, I get basically 4 circles the way I want it, except that this was not right. Let me let me undo this. Try it again. Where was that? Right here. 3 of them. Duplicate mode. I want it to be on. Okay, and right. Look at the very bottom left corner. It says selected geometry. Selected geometry to be rotated. This is the geometry I want to rotate. And again, read the bottom. It says select or click on the rotation center point, and this is going to be rotation center point. And then again, read the bottom left corner, select or click a point, define the reference line for the angle. So let's say that this is my reference line, and there we are. When you're done, just click on it. Now, there are a zillion other ways of doing this thing, but this is what I decided to do. At least show you some of these features that I've never used before. There's offset here. These are very good. What is this thing? It's called scale, outward, inward, etc. Now, exit. Okay. Notice that here I want to use the fill surface. The problem with the fill is that you need to have a closed surface. Someone told me that in a newer version of Catia, maybe R2022X, that they can actually do a non-closed curve. This is a non-closed curve. I can't do it on my. See, when I say okay, it just puts it everywhere. Okay, so it doesn't take those holes into consideration. And cancel that. Okay, good. Now when I try to split this thing, it says select the element to cut that surface. Select cutting element. I want to select these holes, but the problem is that when you do that, you're going to get internal error. Cancel. So here's how I'm going to propose to you. Now let's go back to that sketch. Let's go back to that sketch. The fill is still there. No problem. And I will use this thing called profile. Oh, sorry, here, output features. And I'm going to select these four circles. One, control two, or you can do it individually. Oops. Was that output feature? Sorry. Let's try it again. Output features here. Select this, control that. Maybe if I did it before I actually did, let me undo this for a second. Okay, let's go back to that sketch. Okay, good. Let me select all of these. This guy, control that guy, control this guy, control this guy, and I say output feature. It'll do it all at the same time. Exit. Now notice that the fill is still there, but these things have been created and I can use it for splitting purposes. Just look, split, element to cut is the surface, cutting element of these feature, 1, 2, 3, and 4. Hallelujah. Okay. Now these things you can hide if you want, but they really doesn't bother me, so hide it. If you want one by one, you can hide these output features that were basically created. Hide and hide. Or you can go here. Where is that? In the output features, just hide everything. Okay, good. Now I want to cut this thing and take 1/8 of that. One of the planes is obvious. It doesn't matter. One of the planes, but the other plane I need to create at 45 degree to this, for example, YZ plane or XZ plane. So let's create that. Where is the plane? Let's get, here's a plane. Different ways of making a plane. Where is it? Right there. Take this thing out. And the method that I want to use is, let me see now. There's one angle normal to a plane. Just click on it. It says reference rotation axis, for example, Z axis. Reference is one of these planes. It doesn't matter which one you take. This guy and 45-degree angle. 45-degree angle. Okay, so notice that a plane has been created which is at 45 degrees to that plane that I selected right there. So let's start cutting things. Split. Let's split the element to cut is that surface. Let's do it with one of these regular plane, YZ plane. Good. Now do another one. Element to cut is that surface, and the cutting element is going to be that plane that I created at 45 degrees. I think it's this one, and it doesn't matter which side. Well, I want to keep this side. 1/8 is going to be this side. There we are. Now you could have done this in many other ways. Good. Now I will create a local coordinate system here because later on I want to give a angular speed of this thing about that particular axis. I don't want to create a line here on purpose. I'm going to create a coordinate system, and I'm going to use its z-axis as the axis of rotation. Okay. Now let's make this thing out of steel. And please, you have to understand that I did take you on a detour to create the surface. I want to show you what output feature is, stuff like that. So anyway, there are other ways of doing this thing too. So we are pretty much done here. Now we're going to go to generative structure analysis. And I'm going to use a horrible triangular three-noded element. Let me see now. We'll have to measure it yourself because this is a surface. There we are. Let's make it smaller. And actually, you know what? I'll keep it like this, but I'll show you how to refine the mesh in a certain area around that hole, for example. Let me actually make this thing maybe 0.5. Okay. And if I look at the mesh, right click mesh visualization, you see that you get something like that. Change your rendering so that you can see the element edges. But let's say I want to refine it around that circle. So you just double click on that and select the local and edge distribution. Select this edge. Now we cannot select it because the mesh is staring at us. So deactivate this thing first and do it again. So double click on this local. Let me see now. Edge distribution. This edge, that edge. Okay. So I said select that edge and said add. Let me show you again. Cancel. Start again. See that? I cannot select this edge. You say add, and then it says okay, go pick it. So there we are. Let's make it 10. Say okay, and say okay, and say okay. Now if you look at the mesh, notice that it created a distribution of nodes around that. So if you say show me the mesh, there you can see that there is a distribution of nodes around that edge, which make it finer about that circular edge. Right click, deactivate this thing. Let's move on with the rest of the problem. So let's say that this thing, oh, we have to give it a thickness. Don't forget the thickness. So here's a 2D property on that. And I don't know, make a maybe 1-inch thickness. Good. Okay. Now we're going to create a load here. So here is a angular, what is that? What is called a rotation force. The support is that surface. The axis of rotation is right there. You need a line there or an axis that I created. Otherwise, it won't let you pick it. So let's say 1,000 RPM. Acceleration is 0 because it's a constant velocity. Okay. Now, just yeah. Now, this point, the center of the disk, these are, by the way, planes of symmetry. These lie on symmetry planes. So user defined. You've got to be careful here. You see, if you look at this edge and that edge, they lie on the, I believe, if you look at the coordinate system here, these two edges that I picked, look at this cone, lies in the YZ plane. See that? YZ plane. These two edges lie in the YZ plane. So that means that no displacement in X and rotation is opposite. Now this edge lies in that 45-degree angle. If I had done 90, there would not have been a problem because this edge would have been on the x-axis plane. But on purpose, I selected 45 degrees. So I need a coordinate system, local coordinate system here, which I don't have it right now. Okay, so let's go ahead to the part and create a local coordinate system. Where is that thing? There we are. Origin, I'm going to put it on purpose. Let me hide the sketch first of all. Yeah. At that point, oh, cancel. Let's try it again. Let me hide the sketch. Good. So where's the coordinate system right there? Axis system. It says the origin. I'm going to select this point. And for the x-axis, let's say I select this. So if you look at it, this edge lies in the y-z plane of that local coordinate system. So let's go ahead back to the analysis. Select user defined this edge lies in the not the global coordinate system, local or user, and this is the coordinate system that I want to use. So that is going to be no displacement in direction 3, direction Z, and rotations opposite. Good. Now, in all likelihood, this is still can move as a rigid body up and down. Let's find out. So I think we're good with everything. So let's save the analysis. File save management. This analysis save as, not in this folder. Problem 2. Please make sure you sort these out. Find an exam. I didn't realize that I did not have a. Let me see for a second. Homework 5, problem 2. Yeah, it should be there. Uh, Cancel that. It's the analysis. That's the one I want. Already the part saved in there. That's why I was getting a message. Should I overwrite it? So, okay, good. Now, if I run it, this will probably move up and down because not rigidly, I don't think it's rigidly, yeah, you can see that. So it can only go up and down probably right there. And all I need to do is to select one point and say, hey, you can go up and down. And it really doesn't matter which point. So let's deactivate this guy. All right, let's go ahead and take 1 point. Now, I don't want to mix things up, so I'm going to hide this. I'm going to hide that, although restraint, and I'm going to select 1 point. 1 point, for example, this point, and I say you cannot go up. With respect to let's do it global. It really doesn't matter. Global Z and local Z is the same, but I'll use a global Z. It doesn't matter. You could have used the local one, but then you have to select it, of course. Good. That's pretty much it. So if I run this thing, I'm pretty sure it's okay. Yep, you can see that. So let's change the scale here. Otherwise, you can't see the deformation. Let's change this thing to default. You can see that. Obviously, because of rotational motion, this thing stretches outward. You can see this. Yeah, that's good. You look at the stress distribution, one meter stress distribution, change the rendering here. Because stresses around the anything that you don't like, you can hide there. Okay. And yeah, if you look at the if you look at the view from the top, which is probably more illuminating, there we are. And if you want to look at the displacement, the magnitude of displacement, I mean, this is a big piece of steel, very tiny amount, 1000 RPM, 1 inch thick piece of steel, which is turning at 1000 RPM. That doesn't move that much. I mean, even the stresses were pretty low. So I did a few things that were taking you along a detour of this whole shebang, and hopefully you got to learn